Hello, my name is George Antonopoulos. I am the CTO in Digital Orthodontics for GuideMia Orthodontic Digital Project, and in this demo, we will use GuideMia Ortho Plus software to perform treatment planning. In aligner design, the case has a patient's CT scan model, face scan file, and X-ray panoramic picture. A mouse indication software is used to show which mouse button is used. Red, blue, and green feedbacks are for left, middle, and right buttons. Keyboard presses are shown in the lower part of the screen. First, we create a project by loading the patient's CT scan. CT data is now loaded, 3D reconstruction is finished, and 2D slices are shown. As different views, the mouse movement convention is like this: left button for rotation, and 3D windows or thresholding. In 2D views, middle button is the pan operation. Finally, the right button is for zooming. After loading the CT data, first we adjust the threshold to some low value. In order to create a model for the facial area, we change the region of interest box with the 2D windows and the thresholds using the sliders. Cut the area to finish the model creation. Then, we adjust the threshold so that bone structures are shown properly. Use circle buttons to select the upper jaw and the lower jaw in 2 separate steps. As a general guideline, we suggest for the CT scan to the patient to have the jaw slightly open. This demo actually shows a case that is not very well prepared. It is a live demo for a most common used case. Everything can be adjusted and completely finished. Now we finish the basic CT data processing. Now we load the patient optical scan upper jaw. Then, define a couple of points on the jaw in order to generate a preliminary arch curve. The points need to be placed in a similar order. We place them on the premolars and central incisors. Next we load the lower jaw scan. In this case, having a face scan, a colored image file is loaded. We use the right mouse click to access the context menu and select the register button to align the face scan in the patient's CT scan. 3 points are selected on both sides, and the aligner button is clicked to register them. We can use any number of points for the registration purpose, but in general, 3 points are specified. The points should not be on a line or evenly distributed. Now the facial scan is in its place, and we can then load clinical pictures. The pictures can be in every image format. In this case, we load the X-ray file. In some other pictures, the image viewer can be used to go back and forth to view pictures, and the individual pictures can be added to the 3D scenes too, and overlay with 3D models. This can be useful when we want to simulate some visual effects. Both scans have been processed in our closed solid models. Unfortunately, the files have various quality issues, which we will show later. We will perform automatic fixing operations over the scans, but it is desired to have open shells instead of solid models. On the other hand, very often we receive open shells and want to trim and close them. First we draw a boundary curve of the tooth area, keeping some margin from the teeth. Then use the trim button to finish. The operation, all-in-one fix, is used to fix typical model problems, including small holes, triangle overlapping, self-intersection, sharp areas, topological issues, etc., in just one mouse click. When we want to switch model, we use right mouse click. Tauhe model, with the current same tracking and cut operations, can be applied to another jaw, and then the all-in-one fix operation as well. In this case we can see that the lower jaw has very obvious problem. The fix operation is applied twice, so that we can see the model is well fixed. After such preparation, we can then close the shells and make solid models. The handles are dragged to resize the models. Next, we register the models with the patient's CT scan, similar process as facial registration. 3 pair of points are selected. One of the reasons we suggest to scan the patient with jaws open is that it can be easier to specify points for registration. If a registration is not well done, you can always use the reset button. To start over, click on the next jaw button, and the case will switch to the lower jaw. The registration process is the same. At this point all the model processing has been finished. We will then extract and adjust tooth boundaries. The left window is for the lower jaw, and right window is for the upper jaw. We show the arch curves generated at lower and upper tooth boundaries. In case we need to show and hide objects in the right 3D window, we can use the right-click button and bring up menus, depending on the details on the optical scan, especially the tissue area. The boundary curve may not follow the actual boundary very well. It is necessary to adjust the boundaries. You can drag anywhere on the curve. Use Delete key to remove some unnecessary nodes. Make sure that the curves follow tooth boundaries well. It is important for tooth segmentation. After all this is done, we can move them with tooth segmentation. Now, we go to Segmentation page. Click the Segmentation All Teeth button, and wait for all the teeth till are segmented. If the boundary is well defined, in the last step, the segmentation typically will not need much intervention. The system finished the segmentation. Now after we click the Fix All, for the jaw button, the system will automatically do post-treatment, for the results, including smoothing the boundaries, and fixing interproximate areas, and adjusting the tooth orientations. If for any reason we don't like the segmentation results, we can delete segmented teeth, by right-clicking, and then we can use manual segmentation tools. After the fixing, we further investigate the tooth orientations, and adjust them. Use the middle mouse button, to select, and show orientation widget. Rotate the view, so we can see a tooth from the occlusion side, and then rotate the bounding box, to align, with the tooth and view orientation. With this way, we can fix the tooth orientations. Going one by one, and after this, we can check the FA curves on the buccal side. Then we switch to the lower jaw performance segmentation, and we follow the fixing steps, in the same process. After the tooth segmentation, we want to segment to roots from CT data. Clicking the button, we enter the segmentation mode. In this view, we see the axial view, where you can use left mouse button to adjust the thresholds. The assembly view has an area of the CT data. Surrounding the tooth, we can rotate the view, and change thresholds. Use the circle button to cut the area, until we have the correct root geometry. The Finish button will then create the model, and moving to the next tooth, we will need to create the roots, one by one. However, the root segmentation is optional for both jaws. We can perform this operation, when all crown segmentations, from optical scans are finished, or we can do this process, as one step in each jaw separately. In this case we will need to switch back to the upper jaw, to finish the other jaw too. Once all the roots are segmented, we can move on, with initial tooth setup. Turn one model, and adjust the occlusion plane arch curves. Adjust the arch curves width, and curveness, or adjust individually. The arch curves are supposed to be at the buccal side at this time, meaning the target position of the buccal side of the teeth. We can determine to move the entire curve, back, or forth, depending on how we want the two jaws to be positioned in an articulator. We can change this relationship. For example, we can move the upper curve buccally, or the lower curve lingually, depending on the desired treatment plan. The slide here is used to show the teeth expansion we need to do automatically, starting from the initial phase of the case. This operation will align teeth, according to the curves, and tooth orientations, measuring the interproximate collisions etc. Before this step, we can actually right-click on a tooth, and tell the system not to move the tooth at all. Once the preview is shown, and accepted, we can click the Finalize button. A full simulation is then performed. Another round of automatic placement can be done if we decide to adjust the arch curve, up to other position of the teeth. After the teeth can be individually moved, now click the upper jaw button, to start a different setup. We check the views, and select the tooth we want to move. Placement widget is now shown. We can drag the handles, or drag the tooth directly. If we hide the tissue, we can see the virtual rotation center of the tooth, according to the actual shape. The center can be moved along the axis. If the handle is dragged, the tooth will be rotated, around the center. If you simply pick the tooth, the rotation is done around the geometry center of the tooth. This is for placement only. Later, use the right click to access the context menu. Here turn on occlusion color map, we can see how the jaws are articulated. Moving the teeth we can notice the changes of the occlusion. The brown and red colors indicate the collisions between the teeth. Push anytime this button, to adjust IPR. You can eliminate all the IPR numbers, by adjusting tooth positions along the arch curve. Notice that IPR limits can be set by the user. Now we enter to the planning movement step. First we can play back the movements, turn on and off the bone structures, and roots, change the opacity of the bone. We can review the movements, setting all the possible orientations. If the tissue models are hidden, the playback can be much faster. In the lower part of the window, there is a table, indicating the movements of the teeth in each step. The number of microns indicate the maximum point movement on a crown, at a given step. as we know typically that it is suggested to be a range of 0.2 mm. We can insert steps by right-click on any step of any tooth. We can then play back the movement. Visually, check if there is a need to delay the movements, for some teeth, and set a start step of any new tooth movement. There are many functions in this page. In the context menu, here we mainly show how a keyframe can be set for a tooth, and the tooth can be moved to a different place at that step, so that some spaces can be created for neighbor teeth. If we feel like to, we can go back to planning page, to adjust the target position of the teeth, and come back as well, to plan the movement steps. After the planning is done, we go ahead to align or design page, first to automatically add attachments, or power ridges. Now users can manual add attachments of many other types, and GuideMia is an open system that allows you to find your own attachment collection. Click the tag button, change texts, move the tag to, and then click the button to finish. In order to print aligner models, with a flat platform, an additional step can be taken, to add a platform features for this purpose. Clicking the Generate button, the system will generate all the files. Another option here, is to avoid collisions aggressively during the model generation process. There are times when it is not completely clear to the user, if there are collisions in the intermediate steps. This option will help avoid collisions. At the end of the operation, the system will pop out a message with such information. For each step, the files are exported. In the user pre-selected folder, the file naming convention will indicate the draw, the step order, etc. The output files are standard STL files. We can use any software to view them. In this case, we use MeshLab to view individual steps. In the second try, we designed the aligners. All the aligner models are automatically generated and trimmed. At last they are ready to be printed. MeshLab and GuideMia can both be used to review the design results. Thank you so much for watching our demo. Stay tuned for new updates.